Welcome everyone to this talk about designing workflows for humans, in which we're going to be unboxing dots. So first of all, hello, I'm Nikoline. I am a UX lead at Unity, and I've previously worked on prefabs and 2D tools.
And I'm Kjartan, and I've worked on Project Tiny for the past year and a half.
Yeah, and currently we're working together on improving the user experience of dots. So we have been frequently referred to as kind of the mad design scientists of the design team, because we have a tendency to just kind of lock ourselves in the conference room that has the most whiteboards and just draw some ideas. Today we're going to talk to you about how we're designing the dots workflows. We're going to get into conversion, but it's going to be conversion from the point of view of everyone who needs to be familiar with it and needs to use it. We're going to actually show you how you might build something with the current version of the dots workflows. So we have a little demo. Hope it goes well. We're going to share some of those like mad scientist dreams that we have about the future of these workflows. And finally, we're going to tell you how you can get involved.
So we have dots. And let's talk about what that means for you all.
So if you're writing game code, as I'm pretty sure a lot of people in this room know, it's going to mean a new way of programming. And that's awesome, that's great, but we're not the right people to get into that. There are a bunch of great sessions this week to talk about that by the experts that actually wrote those new systems. Do I need to like go over here? Okay, awesome. Yeah.
If you design and build worlds, it means that they can be more expansive and have richer content. And if you're creating smaller experiences, it means they can be faster, they can be quicker to load, they can consume less of your players' batteries. And that's what we are here to talk to you about today, is how you can accomplish these goals. And we're going to show you the first iteration of some of the workflow improvements that we're making, along with some of the ideas we have for the future of dots. And all of this comes back to the idea of making dots workflows for everyone. And when we say everyone, we're talking about the artists, the designers, the programmers, people working in QA, basically everyone that helps make sure that a game actually sees the light of day.
And we know that we already have a pretty good foundation of how people work in the Unity editor. So we're not here to kind of change all of that. I mean, unless it's for the better. So the design problem that we're tackling is the idea that currently dots is kind of magic. If you are an artist or a designer working in the editor, ECS is not exposed in any way, and this makes it very difficult to collaborate with a programmer, and it makes it very hard to reason about what's actually going to happen at runtime once you're done working on your visual assets.
And the same problem goes for developers who are troubleshooting and figuring out how their content is going to be converted and affected by the systems that they write, because they've described it as a black box, and they don't really see what's going on until they actually get into runtime.
So that's really what we're trying to do together. We're unboxing dots, which means we're surfacing these conversion workflows in the editor in a way that you can see and that you can interact with. And the way we're going about it is that we are defining some design principles in order for us to create these experiences. So what we're really aiming for is a familiar editor experience. We're designing complexity on demand. We'll get into what that means later. And we're also designing workflows that are adaptive to any scale.
So when we talk about a familiar editor experience, we know that the Unity editor has built up a lot of love over the years. We've been going for about 15 years now. And we really want to give you all the benefits of working in a data-oriented way, which means massive editor tools, massive worlds, all the performance to actually work with all of that. But we want to give you a jump start with everything you already know. And so we're going to be making some changes, but we want you all to feel empowered by the years you've already spent in Unity and feel like you have a good jumping off point.
And when we're talking about complexity and demand, it's really this idea that you need complexity for certain things that you're trying to do. So game development is inherently a complicated thing to try to do. But depending on the task that you're doing, an artist, a designer, a programmer, you might not need to see all the information at any point. So what we're really trying to give you is an easy way for you to move between those different layers of complexity depending on the information that you need to consume.
And finally, DOTS brings some scale to Unity, not just at the massive end, but at the tiny end. And that means that all the workflows we create have to scale to that as well. And that's not just from a content perspective. That means tiny to large experiences. It means the project size, and it even means your team size, whether you're an individual developer or a team of 500.
So with all that in mind, let's think about conversion for everyone. So conversion is this thing that we're doing at Unity in order to get you the power of dots as fast as possible. But what we're really thinking about is how we can design those workflows so that they make sense for everyone to use. So there's been a just like very technical talk in this room, I thought it was really good, very deep technical talk in this room right before this session. So we're not going to go into those details. We're going to keep things very high level. What we are going to talk about is the different outcomes you can get from conversion and how we're visualizing that in the design.
So at a high level, conversion is what lets you continue to work with game objects in the editor. It means that you create your game the way you always have, using the classic Unity features you always have. And when the game plays, i.e. when you hit play or when you make a build and your player actually runs the game, we'll handle the process of converting it all so that it makes it easier for the computer to process. We'll convert your game objects to entities, your classic Unity features into the ECS versions of those features, and we'll even handle most of your components by default, unless sometimes you want to actually do some custom conversion behavior, in which case you can write all of that. The only thing that's really different is going to be the way you write code that's going to run, which means this gives you tools for your designers, your artists, to continue working the same way they always have.
So this looks pretty simple, right? Game objects while you work and entities when you press play. Great. So in reality, it's a little bit more complicated. So what we do is we take a game object, we create an entity for that in the conversion world, we run conversion systems, we create an entity in the destination world, which is usually your game world, and then we take those converted components and we create entity components out of that. Now, this is a simple example. It's kind of one-to-one. We have a game object with component A. We go through the whole process, and we end up with entity component A. Great. I think that if we only needed to visualize this design, we could have been done, and we could have gone and got coffee or something, right? So this is the thing that's simple to understand. However, we have some other examples as well. Here we have, if we have game object that also has components B and C, we can see that they are getting picked up by a conversion system called B plus C conversion, and they're getting actually, from them, we're creating entity component X. So it's like an example of two things becoming one. We can think of more complicated examples, such as if we look at game object 2, it's got component E. And E conversion system looks for component E, and then what it does, it actually goes and gives a child entity object based off of that component. So now we have a component that turns into a child entity. Interesting. We can also have examples where one authoring component becomes many runtime components. And if we don't have a conversion system that's looking for a particular type of component, it might just get dropped. So there's a lot of complexity here, and this is what we've been working on visualizing, and I guess we're still on that path.
So all that sounds fairly complex, so let's actually start to go over why that's important. First off, as we said, it means you get your existing tools and workflows. It means that we handle converting your transforms, your rigid bodies, your colliders, your mesh, all this stuff, you get to work with it in the way you always have, and it gets converted afterwards. It means you get free performance benefits. Well, almost free. You still have to write your gameplay code as ECS code, but we've also seen that that tends to result in a cleaner and more maintainable code base.
Pretty cool. It's also giving us and programmers in the room the ability to write your components both optimized for data layouts and for authoring. So we spoke to studios who've already been using this type of game architecture before, ECS type-like, and they told us that they were actually already writing a lot of their data code in a way that was optimized for artists and designers. Because if you think about it, if you have a designer who's going to be tweaking a component, working with some values, you want to give her a component that makes sense for her and some values that she can actually use and that makes sense. You don't necessarily want to write that component optimized for your runtime. And that presents a problem. That's a challenge, and that means you take a performance hit. So we think that this thing that we're doing, where we're keeping game objects and we're converting that to entities at runtime, kind of gives you the best of both worlds, in that you're going to be working with what we're going to refer to as authoring components and then runtime components.
So let's take a look into Unity and actually see how you might build some of that and take a bit of a deeper look than what was shown in the keynote. So here, let's say I'm a level designer. I've got some classic Unity experience. I know how to prototype some stuff in monobehavior, but none of it's very efficient code or anything like that. And I've built out a level here where I have a goal. My player's supposed to get through that door at the top. No way to get there, and I've decided I want to put an elevator in. And so let's say I take my elevator in here. I'll drop it in, I'll move it roughly where it needs to go, to be placed at the bottom here. And this is just a standard game object. And let's say I wrote an elevator monobehavior component. I know roughly where it needs to be. I can hit play. Hopefully. And I see it work. The elevator goes exactly where I need it to, and I was able to make something with monobehaviors.
Yeah, so at this point, you're still working with monobehaviors, right? So as you were kind of talking, I actually made you an elevator system that can work with all of this new entity stuff. So do you want to try that?
Yeah, let's give it a go.
I mean, you don't actually need to change components because I wrote a conversion system for you. So if you just get the game object set up for conversion, it's just going to work.
Cool. Do you want to walk us through how I can set it up for conversion?
I absolutely do. So there are two ways. If you just want to do a simple conversion of that object, you look at the object header, where we now have this neat little box that says convert to entity. So if you check that, that means that this particular object is going to get converted to an entity at runtime. So you will also notice, if you were observant, it's okay if you're not, at the bottom of the inspector we have this nice new preview section down there, and you might have seen that in the keynote. You'll also see that it's empty. Yeah. So if you want to actually take advantage of this fact that we have this nice preview, we need to use a subscene for conversion. So if you go ahead and just uncheck that box that I told you to check, great. And if you go and find your game object in the hierarchy, and you can right-click on that, and then you can create a subscene around it. Yeah, so now we see that we can actually see the components that I used for the elevator system. And you can hit play, and we can see if things are running correctly. Yeah.
Looks like it's still running, and this time it's an entity.
We see no difference at all, but this time it's an entity, and you're just going to have to trust us on that.
So next, we can actually take a deeper look at how we can start a live link build, because that was previewed in the keynote yesterday, where we were actually able to put a build somewhere else, connect it up to our editor, make changes in the editor, and see them happen live. Now, we don't get the fancy setup from the keynote where we had 3 different machines and a couple of mobile phones and everything else. So we're going to run the live link build locally, but it's actually still the exact same process of creating a build, putting it on a device, hitting play, and seeing it connect up to the editor. And so what I've done here is I've gone ahead and set up a build configuration for myself to create a live link build. And I'm going to hit build and run.
So while that's doing a quick build, we're working on it, we want to briefly go over subscenes, which is now the recommended way to work with entities in Unity. So when you create a subscene, that's a way to tell Unity that everything inside of this subscene should be converted to entities. And not only that, as we just saw, it gives us a way to see a live preview where we can actually select an entity and we can see our sort of live link functionality. Yeah, we should have put more clever banter in this part.
We really should have.
Really should, yeah.
But what we can say is that that behavior of subscenes to convert all of the game objects within them is something that we hope to eventually bring to root scenes as well, to where you can just create scenes and set them up for entity conversion, and then rather than having to create subscenes or marking things for conversion, you can just convert your entire scene right off the bat.
Yeah, that's definitely where we see this going in the future. This is one step towards having to do less manual work to get stuff set up. But we want it to be a place where you go, you open up things, and it just kind of works.
Yeah.
Minus the kind of, it just works.
Yeah, hopefully it actually just works. So what we see here is we have a running build, we have entities in there, and we can take a look at it.
I mean, that looks good, but I think I have some design notes for you. I'm not sure that it's very clear for the player that they actually need to get to the door. It looks like it's just kind of floating in space. What's up with that? Can we place something there to kind of guide their way and make it maybe more appealing to look at?
That's a really good point. I think I've got a light prefab ready just for that. So I'm going to jump back into Unity here. And let it open up. And I'm going to take my environment subscene. I'll open that for editing. And I'll take my light here and pull it in. So now I've got a nice light. I can position that roughly where I want it, maybe right above the door?
Yeah,
something like that.
Looks good, yeah.
Get a nice spotlight on it all. And then when I hit save, that's going to be Unity's signal to start to bundle all of that up and send it over to the player. And so if I go to my live link player now, we have a light ready to go. And that's the power of this, is that you might have some upfront build time, but we could put this build on a PlayStation 4 in the living room or anywhere else, really. We could have it on 3 different computers next to us. We could have play testers all going, and we can just start making changes and see how it feels live for anybody playing the game. So
that looks great. I think that made a huge change. So let's go back to the presentation, and let's see how we've actually gone about designing these workflows, and as well as some previews of what might be coming up for us in the future.
So one of the first things we talked about was creating a familiar editor experience for all of you. And let me highlight some of the things that we just saw. First, I made stuff with game objects. I used classic monobehavior components, and I didn't have to worry about entities or ECS or dots or any of that. And I was able to prototype something with a monobehavior even. I wrote my logic as in object-oriented programming, and it all worked fine. And then my programmer came along, and she wrote all the ECS back-end systems. She wrote the conversion. I didn't have to change anything in the scene, and then it synced up with all the other entities in our scene. And even in play mode, I could continue to tweak the values of the elevator, of the light, of whatever I needed to, with the same components that I was using as I was building it.
So the second thing we talked about is complexity on demand. Now, when you saw Kjartan working, you might notice that, as he's working, as he's grayboxing stuff out, he does not necessarily need to see a preview of the entity data or components. So that's why we made the preview at the bottom of the inspector, and it's collapsible. So if you don't need this data, you don't have to worry about it. Now, let's say he does want to sort of see a simple case of, just as I'm converting this object, what's going to come out of it, right? So at the first level of this, we just see your runtime components. He might dig further into that data. He might actually select some of those runtime components, and he might see the actual runtime data that's getting created. Now, for now, this is initial state. But we would really like to get to a point where this is showing you, as you're playing the game, a live conversion. And then this is a little bit in the future. We think it would be very useful to be able to filter per authoring component. So here, I've kind of went and said, I want to see for the mesh renderer, which runtime components are we going to get from that. And this is, again, thinking back to the diagram that we showed you initially with all of these different conversion results. We don't want to throw that diagram in your face, but we do want you to have ways to basically dig into that data so that if you do need to debug what's going on and understand what's happening, you can find that information.
And finally, we said things needed to be adaptive to any scale. So we went all the way back to Megacity from last year, and we took the player vehicle, which at the time was a game object, and we said, what if we convert this to an entity? What if we write the conversion script to take the player vehicle controller and make that 6 different components so that the computer could run it really well? And we discovered that's a lot of data. And so we realized that this display of authoring and runtime data needs to scale to larger objects as well. And this is where this came in that we could easily separate out the preview window from the inspector, dock it right next to it, and look at the authoring data and the runtime data side by side and just go straight down and understand how one thing converts to the other and see even changes to the player vehicle controller and see them reflected in the player vehicle settings on the entity itself.
Yeah. And again, this is at that point where you really need all of that detail. And this is an important point, right? Because not all of you are going to need that detail in your workflow, but you're going to need ways to easily access it.
So that was kind of round 1. That's the first iteration of improvements to Dot's editor workflows. But now, where do we go from here? Because the design process is never done. Like we said earlier, we have some mad scientist dreams. Dots is a very inspiring thing. And so this is where we're going to start talking about some of those mad dreams. And we're going to put in a disclaimer that nothing here is guaranteed.
So you saw lots of you probably saw the keynote yesterday. So we want to talk a little bit more about Live Link and how we're kind of thinking about that user experience. So the basic of it is this idea that we should be able to live iterate on device, right? We should have a streamless loop of iteration where I can just make something, see it update. I never have to actually go and check something after the fact. I can see things as they're changing. I don't have to wait for build or play. I can just be in the loop as I'm working and iterating. And personally, I'm really excited about this. But this is also because my background is like UI design and that kind of stuff. So I'm like, I just want to see the button move, So it's going to be great. So the way we're thinking about the UI for this is basically kind of as a list of devices where I have some devices that are connected, some things that I might be able to connect. And then, as a device is connected, we see the same thing on that as we have in the editor. And, as we're kind of changing things in the editor, we see the changes on the device, okay? But the sky is really the limit on this. Like, what I'm thinking in my head is, when we think about the amount of devices people have to target, or you all have to target for the experiences you're creating, this could really give you a big boost. I also think that while this is great for one-person iteration, it has some really nice implications for collaboration in studios where, as one person is iterating, another person is playing, a third person is playing, and everybody's just like kind of contributing to that, so that when we're prototyping, we're playing around with concepts, we're trying out things, or we're finding bugs and all these things, we don't have to wait a lot, but that change, that update can kind of be instant. Yeah.
Oh, that was the right one.
We were on the right slide.
We were on the right slide.
We
That's
were.
my bad. And as we think forward on LiveLink, we really hope that it's going to become sort of an extension of play mode, where you can play locally or you can play remotely, and you can actually pull the data from you're playing on your Switch and you want to make sure that some of the data values on a particular entity are correct. You can pull that back into the editor and you can watch as things go, and you can really get a sense of how your game is running on any particular device. One of the other things that we heard from all of you that you really want is you really want some way to see the systems and the jobs that are running in your game. And so what we want to do is actually help visualize your game loop in the way that it's running, in the dependencies that happen, the order systems run in, the dependencies between jobs as they're running concurrently. And we want to show you all of that in as intuitive a way and in easy to understand a way as possible.
And to add to that, to also show it in a way where you don't necessarily have to have this window up all the time, but that we can find ways to show connections between objects, systems, and components in the workflow where you already are. So that's at least what we're talking about when we're locking ourselves in the conference room. So, back to mad scientist dreams. Again, this is like very, very future stuff, but we're basically thinking about live iteration. We're thinking about visual scripting. We're considering how we might visualize your full game loop for you. And we've got a lot of other things that we're kind of tinkering with. I think it's fair to say that this new change of direction for Unity in terms of like focusing on dots and getting in on performance, it really opens up a lot of things for us also in terms of workflows and in terms of workflows that scale to new experiences and allow us to do things that we always kind of wanted to do but never really thought were possible. So it's all very exciting stuff.
But before we head too far down that path, we actually need to continue learning what you all need. And that comes with research. So we sit down with you, whether individually or in small groups, and learn what you need, what problems you're facing, what it actually takes to solve some of those problems. And then we use that to inform our roadmap, the efforts that we take, and more.
Yeah, and the process is familiar to you. We iterate, we test, and we repeat, and it's the only way to make anything good. And the testing part is where we really, really need input. Because ultimately we have one goal, which is we want to make data-oriented the new normal. And we are looking to achieve this by building on a familiar editor experience, by designing workflows that allow you to access complexity only when you need it, and to create things that scale, both in terms of how you work in the editor and what you're able to create from the editor.
So, in pursuit of that goal, we need you to help us to help you. And ways you can do that are by signing up for user research, where you can, as I said before, tell us about your problems, tell us what you need in order to create world-class content. And you can even test some of the new prototypes, designs, and thoughts, features that we're coming up with.
Yeah, tell us where it's all wrong, and then we'll, work on it and make it better. And finally, you can also just let us know what you think. We're on the forums, we're on Twitter, and we're also going to be on the conference floor this week. So grab us, tell us what you think about dots. Is there anything you're scared about? Is there anything you're excited about? And if you have any mad scientist dreams, we would really love to hear about them.
So thanks very much. We've got some time left, so yeah.
Yeah,
So
we have
we've
some time
actually
for QA, and there are microphones in the back. I'm sure you guys know the drill.
Yeah, we'd love to start a discussion now even.
Yep, that would be great.
And we can't see you, so.
And we can't see anything, so. Right, we'll just
Hello?
give-
Hello?
Yes?
Here? Yes. Hi.
Hi. Oh, hi,
There you
hi.
are.
Hi
down
there. I have a quick question.
Yeah.
When you build that project, that scene, you use a custom inspector, some kind of custom inspector. Where that inspector comes from?
Were you talking about the conversion preview at the bottom of the inspector?
No, you built the scene in Unity using a custom inspector, a button in a custom inspector.
We were using a custom inspector?
Well, yes, some kind of custom tool that is not part of the Unity.
I'm going to go back and then let's see if we can find it. We know what we're talking about.
Oh,
No, can you show
the
your
build
laptop?
configurations.
Oh.
Yeah. So that is something that's very much under development, but it's currently what is letting us do the live link builds.
Oh, yeah, in the demo. Right.
Yeah, in the demo. So it's what's currently letting us do the live link builds, and it's part of what we had on one slide about exploring some ways of reimagining the ways that you build and export your game from Unity. And so right now it's very much a prototype that's just kind of sitting in the background.
Okay, well, that was very practical. It was good, really good. Thank you.
Yep.
Sure. More questions?
Hello.
Otherwise,
Hello?
I'll just start talking
We have
again.
one over here.
Okay, yeah,
There.
great.
Can you hear me? Yeah, okay. I have a question about this lifelink thing.
Yeah?
Is this working for the mono behavior components as well? So can I edit this live in the lifelink as well, or is this currently restricted to ECS things?
Okay, so the question is, for live link, does it also work for mono behaviors, or is it restricted to ECS?
Yes.
It's restricted to ECS because of the way that we do the data transfer, and essentially that's what allows us to make sure that, for example, take the light, when we actually saved that subscene and sent it over to the running player, the only thing that got sent over was the light itself. Even the rest of that subscene didn't have to get sent over because it remained unchanged, and we can only really do that with the way that ECS is built up in the editor currently.
Okay. And in terms of mad scientist dreams, I would really love to collaborate with a VR player, building VR worlds in the editor and the VR goggles.
Yeah, that'd be
Nice.
pretty great.
Yeah, awesome.
Hi.
Hi.
I've got a question related to LiveLink as well. Is it possible to change component systems and job component systems as well, or is the live change restricted to entities and the data layer?
So the question is LiveLink restricted to entities and data, or is it possible to hot reload code? Is that correct?
Yes, basically.
Do you want to? No? So for right now, that is absolutely the case. Hot reloading code is a very difficult problem to solve. But what I can say, at least, is that it's one of the mad scientist dreams to get that to the point where we can hot reload code in a running system or a job or something and switch that out in a running player. But that's not the case yet. It's not a guarantee, but it's something that we'd really love to do.
Yeah, exactly.
All right.
That's what I thought.
Any other questions? Going once? Going twice? Sold.
All right.
Thanks very much, everyone.
Thanks for coming.